Good morning, dear students. Today I am going to explain chapter 3 for class 10, that is metal and non-metal. Dear students, as you know, there are 118 elements known at present, and on the basis of their properties, these elements have been classified into metals, non-metals and metalloids. Dear students, we have divided this chapter into two parts. In the first chapter, we will discuss about properties of metals and non-metals. And in the second part, we will discuss about the extraction of metals from its ores. So dear students, now I am going to explain the properties of metals and non-metals. So first of all, I will describe here the physical properties of metals. Dear students, as you have studied earlier, metals are solid. But you must remember that, yes, metals are generally solid, but single metals, mercury, is found in liquid state. Dear students, metals' second physical property, metals are hard, but some metals are soft, like lithium, sodium and potassium are soft, and lithium, sodium, potassium are metals, but these are soft and can be cut with knife. Dear students, metals are malleable. You may ask, what does malleable means? Dear students, malleability is the property of a metal by which a metal can be hammered into thin sheet. So metals are malleable. Metals are ductile. What is ductility? Ductility is the property of a metal by which a metal can be drawn into thin wires. Metals are lustrous. Metals have shining appearance. But you must remember that sodium is a metal which can lose its shining appearance within a few seconds. So these are the exceptional cases. Dear students, metals are good conductors of heat, but lead and mercury are the poor conductor of heat. Dear students, metals are good conductor of electricity. Metals have high melting and boiling point, but lithium, cesium, gallium, sodium and potassium have comparatively low melting points, especially gallium and cesium have very low melting points, and even these can be melt upon our palm. So dear students, you must remember, again I am going to summarize the physical properties of metals. Metals are solid, metals are hard, metals are lustrous, metals are malleable, metals are ductile, metals have high melting point, and metals have high boiling point, and metals are good conductor of heat and electricity. But you must remember the exceptional cases, like I had told you earlier, that metals are solid, but mercury is a metal which is found in liquid state. Metals are lustrous, but sodium is a metal which can lose its shining appearance within a few seconds. Metals are hard, but lithium, sodium, potassium, these are metals, but these are soft and these can be cut with a knife. Dear students, metals have high melting and boiling point, but lithium, sodium, potassium have comparatively low are soft and comparatively low melting points, but especially cesium and gallium have low melting points and boiling points. Now we will discuss about the chemical properties of metals. Dear students, Metals are electropositive elements. You have heard the many metals like iron, sodium, potassium. These are metals, but metals are electropositive elements. Electropositive means the tendency of a metal to lose its electron. It's called electropositivity. For example, if we talk about here sodium loses its electron to form sodium ion. So when sodium atom loses its one electron, it becomes sodium ion. So this tendency of a metal is called electropositivity. So we can tell that the metals are electropositive element. We are taking another example. For example, potassium. Potassium loses its one electron and becomes potassium ion. So when a metal has a tendency to lose its electrons, so we can say that metals are electropositive elements. Second properties are metals are reducing agents. Dear students, you have studied in the chapter 1 about the reducing agent. Here I am taking an example. When sodium ion reacts with chlorine ion, it combines and forms sodium chloride. As you have studied earlier, on the basis of gaining or losing of electrons, oxidation and reduction takes place. So here sodium loses its one electron, so sodium gets oxidized. Dear students, here chlorine gains one electron, so chlorine gets reduced. But if sodium gets oxidized, the chlorine helps in the oxidation of sodium. So here chlorine is the oxidizing agent. But in this reaction, if you talk about a metal, chlorine gains one electron to becomes chloride, and so chlorine gets reduced. And in the reduction of chlorine, sodium helps. So sodium is a reducing agent in this reaction. As in this reaction, sodium helps in the reduction of chlorine. So sodium is a reducing agent. Once again, please remind this, all the metals are reducing agents because it helps in the reduction of nonmetals and any other thing. So metals are reducing agents. The third property we are discussing, third chemical property, reaction of metal with oxygen. Dear students, reaction of metals with oxygen. So when metal reacts with oxygen, it produces metal oxide. So when metal reacts with oxygen, it produces metal oxide. But you must remember that some of the metals react with oxygen at room temperature, at atmospheric temperature, but some of the metals react with oxygen on heating, or you can say on strong heating. But some of the metals react with oxygen on prolonged heating, and some of the metals do not react with oxygen. So you must remember this, but generally you know that when a metal reacts with oxygen, it produces metal oxide, and metal oxides are basic in nature. But you must know which metals can react with oxygen at atmospheric temperature. As you know, some of the metals react with oxygen on heating or strong heating, and some of the metals react with oxygen on prolonged heating, and even some of the metals do not react with oxygen even on prolonged heating. So you must know that some of the metals which are highly reactive in reactivity series, like sodium, potassium, calcium, these are highly reactive. So these elements, when react with oxygen at atmospheric temperature, and can produce their oxides. So when sodium reacts with oxygen, it produces sodium oxide. In the same way, when potassium reacts with oxygen, it produces potassium oxide. When calcium reacts with oxygen, it produces calcium oxide. So these three metals can react with oxygen at atmospheric temperature. Dear students, you must remember that sodium, potassium and calcium react with oxygen and produce their oxides at atmospheric temperature. But dear students, some of the metals like magnesium or zinc or aluminum, these react with magnesium, zinc and aluminum. If we talk magnesium, zinc and aluminum, magnesium react with oxygen on heating and it produces magnesium oxide. In the same way, zinc reacts with oxygen on strong heating and it produces zinc oxide, and aluminum reacts with oxygen and it also produces aluminum oxide, but these reaction takes place on strong heating. So dear students, once again I am repeating this: sodium, potassium and calcium can react with oxygen at atmospheric temperature, but magnesium, zinc and aluminum, such type of moderately reactive elements or metals, react with oxygen on heating or strong heating. But some of the metals about iron and copper, so when iron and copper reacts with oxygen, it produces iron oxide, but this takes place upon on strong or prolonged heating. Copper reacts with oxygen and it produces copper oxide, but this reaction also takes place on prolonged heating. So you must know that iron and copper, such type of metals, react with oxygen and can produce their oxides, but on strong and prolonged heating. But silver, gold, platinum, such type of metals do not react with oxygen even on prolonged heating. So now I am going to summarize the reaction of metal with oxygen. Dear students, when a metal reacts with oxygen, it produces metal oxides, and metal oxides are generally basic in nature. Dear students, but sodium, potassium and calcium can react with oxygen at atmospheric temperature, at room temperature, and can form their oxides. But magnesium, zinc, aluminum, these elements react with oxygen and form their oxides on strong heating. But iron and copper, such type of metals, can react with oxygen and produce their oxide on strong and prolonged heating. And silver, gold, platinum, such type of metals do not react with oxygen. Now we will discuss about the reaction of a metal with water. Dear students, what happens when metals react with water? We are writing here metal plus water. When metal reacts with water, it produces metal hydroxide or metal oxide, and hydrogen gas is released. You must remember this: when metal reacts with water, it produces metal hydroxide or metal oxide, and hydrogen gases are released. But you must remember that when metal hydroxides are released and when metal oxides are released. So first of all, you must remember, when a metal reacts with water, it produces either metal hydroxide or metal oxide, and hydrogen gases are released. For example, when sodium reacts with water, it produces sodium hydroxide and hydrogen gas are released. So sodium reacts with water, it produces sodium hydroxide and hydrogen gases are released. Dear students, you must remember that sodium, potassium and calcium, these three highly reactive metals, can react with cold water. So same way, when potassium reacts with water, potassium hydroxide is formed and hydrogen gas is released. And when calcium reacts with cold water, it produces calcium hydroxide and hydrogen gases are released. So you must remember this, sodium, potassium and calcium, which are highly reactive metals. When these reactive metals react with oxygen, it produces their hydroxides and hydrogen gases are released. And one more thing you must know, sodium, potassium and calcium can react with cold water. But magnesium does not react with cold water. Magnesium can react with hot water and steam. One, you must remind this, magnesium when react with hot water, it produces magnesium hydroxide and hydrogen gases are released. But when magnesium reacts with steam, that is also water, so you are writing here H2O for steam, for hot water, for cold water, we are writing here H2O. So when magnesium reacts with steam, then it produces magnesium oxide and hydrogen gases are released. But some of the moderately reactive metals, like we talk about zinc, aluminium and iron. So zinc, aluminium and iron reacts with steam and produce their oxides. Dear students, for example, zinc, aluminium and iron. So when zinc reacts with water, it produces zinc oxide and hydrogen gas are released. Dear students, when aluminium reacts with water, it also produces aluminium oxide and hydrogen gases are released. And the same way, iron also reacts with water and it produces iron oxide and hydrogen gases are released. So you have seen here, when metals react with water, it produces either their oxides or hydroxides and hydrogen gases are released. What you must remember here is some of the metals can react with cold water, some of the metals can react with hot water, and some of the metals can react with only steam, and some of the metals cannot react with water even with steam. So you must remember these things. So once again I am going to remind thee, like the most highly reactive metals like sodium, potassium and calcium, these elements can react with cold water and can produce their hydroxides and hydrogen gases are released. For example, when sodium reacts with water, it produces sodium hydroxide and hydrogen gases are released. So I have written here Na plus H2O, NaOH plus H2. But magnesium does not react with cold water. Magnesium reacts with only hot water or steam. Here you must remember that when magnesium reacts with hot water, it produces magnesium hydroxide and hydrogen gases. For example, I have written here Mg plus H2O, MgOH whole 2 plus H2. But when magnesium reacts with steam, magnesium produces magnesium oxide and hydrogen gases are released. So magnesium plus H2O, MgO plus H2. But some of the metals like zinc, aluminium and iron do not react with even hot water. So zinc, aluminium and iron can react with only steam. So when zinc reacts with steam, it produces zinc oxide and hydrogen gases are released. Aluminium reacts with water and steam, it produces aluminium oxide and hydrogen gas. Iron also reacts with steam or vapor and it produces iron oxide and hydrogen gases are released. And gold, silver, platinum, such type of metals do not react with water even with steam. Dear students, here you must remember sodium, potassium and calcium reacts with cold water. Magnesium can react with hot water and even with steam. And zinc, aluminium and iron can react with steam only. And silver, gold, such type of elements do not react with water. When metals react with liquid form of water, it forms hydroxides and hydrogen gas, and when a metal reacts with steam, it produces oxides and hydrogen gases. Dear students, now we will discuss about the third chemical property of metals, reaction of metal with an acid. Dear students, what happens when a metal reacts with an acid? As you know, when a metal reacts with an acid, metal salt is formed and hydrogen gases are also evolved. So, metal plus acid, arrow, metal salt plus hydrogen gas. So, when a metal reacts with an acid, metal salt is formed and hydrogen gases are also released. So, metal, I write here sodium plus HCl, it produces NaCl plus H2. But you must know that in the reactivity series, as you have studied in class 8, the metals which are placed below hydrogen cannot react with acid. So, copper, silver, gold, platinum, such type of metals do not react with acid. But those metals which are placed above hydrogen can react with acid and can form metal salt, and hydrogen gases are released. Dear students, now the next chemical properties of metal, what happens when a metal reacts with another metal salts. The dear students, when the more reactive metal reacts with the salts of less reactive metal, then it can displace the less reactive metal and form their salts. For example, reaction of metal with other salts, when iron reacts with copper sulfate, it produces iron sulfate and copper is formed. In this reaction, iron is more reactive than copper, so iron displaces copper and form their salts. So these are the main chemical properties of metals. Now we will discuss something about nonmetals. Here I would like to focus about amphoteric oxide. It has been left. Dear students, the oxides which show, generally you know that metal oxides are basic in nature, but some metal oxides show acidic as well as basic behavior. So these such type of oxides are called amphoteric oxides. In the metal oxides which show acidic as well as basic behavior are called amphoteric oxide, like aluminum oxide, zinc oxide, lead oxide. Such type of oxides so acidic as well as basic behavior. So these are called amphoteric oxides. Now we will discuss about nonmetals. Dear students, as nonmetals may be solid, liquid or gaseous. Some of the nonmetals are solid, like carbon, sulfur. These are found in solid state. Only a single nonmetal is found in liquid state, that is called bromine. Bromine is found in liquid state, and some of the nonmetals are found in gaseous state, like hydrogen, nitrogen. These are found in gaseous state. So nonmetals can be found in solid, liquid or gaseous state. Nonmetals are not hard, nonmetals are not lustrous, but iodine is a nonmetal, but iodine has luster. Diamond is a nonmetal, but it has luster. These are the exceptional cases. Generally, nonmetals are bad conductor of electricity, but graphite, which is a nonmetal, is a good conductor of electricity. Nonmetals have comparatively low melting point and boiling point, but diamond has high melting point. Nonmetals are not hard, but diamond is the hardest substance in the nature. But when we talk about the chemical properties of nonmetals, so dear students, when nonmetals react with oxygen, it produces nonmetallic oxides. So we can write here nonmetal plus oxygen, nonmetallic oxide is formed. I am talking about if we take carbon, which is a nonmetal, when it reacts with oxygen, it forms carbon dioxide. It is a nonmetal. But dear student, nonmetallic oxides are generally acidic in nature. For example, when sulfur reacts with oxygen, it produces sulfur dioxide. It is a non-metallic oxide and it is acidic in nature. But some of the non-metallic oxides are neutral also. For example, carbon monoxide and water are neutral oxides, as these are non-metallic oxides, but these are neutral. So you must remember that generally non-metallic oxides like sulfur dioxide, carbon dioxide, nitrogen oxide, these are acidic in nature, but some non-metallic oxide like carbon monoxide, water are neutral oxides. Dear students, nonmetals are electronegative elements. As you know, the elements which have tendency to gain electron is called electronegative elements, and nonmetals have tendency to gain electrons. So nonmetals are electronegative elements. For example, chlorine, when gains electron, it produces chlorine ion or chloride ion. So we can say that nonmetals are electronegative elements because it has tendency to gain electrons. Nonmetals are oxidizing agents. In the reaction of Na plus sodium ion plus chlorine ion, when it reacts, it forms sodium chloride. Here nonmetals act as oxidizing agent because it helps in the oxidation of sodium. So nonmetals are generally oxidizing agents or strong oxidizing agents. So these are the chemical properties. Nonmetals do not react with water. Nonmetals do not react with acid. Dear students, now we have studied about the physical and chemical properties of metals and nonmetals. Now we will discuss a point on ionic compound. Dear students, what is ionic compound? The compound formed by the combination of ions are called ionic compounds, as metals form cations because it loses its one electron or more electrons. Nonmetals forms anions. So when cations formed by metals and anions formed by nonmetals are held together with a strong force, it's called ionic bond. And the compound formed by the combination of cations and anions are called ionic compound. Sodium chloride is an example of ionic compound. Potassium chloride is an example of ionic compound because sodium chloride is formed by the combination of cation, that is sodium ion, and anion, that is chloride ion. So it is called ionic compounds. Dear students, there are some properties of ionic compounds. Ionic compounds are hard. Ionic compounds are strong because due to strong forces of attraction between the cations and anions. Ionic compounds are a good conductor of electricity in molten state because ionic compound can produce ions in molten state or in aqueous solution. Ionic compounds have high melting point and boiling point because there is tremendous amount of energy is required to break the bondation between cations and anions. So ionic compounds are hard, ionic compounds are generally solid, ionic compounds have strong forces of attraction between them, ionic compounds are good conductor of electricity, ionic compounds are soluble in water but insoluble in ether, in petrol, alcohol, diesel, such type of covalent compounds. So these are the properties of ionic compounds. So now that is the end for today. In the second part of metal, we will discuss about the extraction of metals from its ores. Thank you.